Good day, everyone. I'm excited to share with you our solution termed as OPTIM AID, which is a pharmacist co-pilot system for the management of insulin titration in our inpatient setting. As we know, diabetes is a global medical problem due to the lack of insulin secretion or due to insulin resistance or both underlying conditions. The challenge in our hospital is that the administration of insulin is typically manual and protocol-driven at the moment. This is time-consuming and at the same time prone to error. Coupled to the variable nutrition, comorbidities, and co-medications of our patients, it further complicates the control of sugar using insulin in our hospital. To solve this clinical conundrum, it requires intermittent glucose monitoring by our pharmacists and nurses in the wards. This requires high workload and at the same time result in poor personal care of our patients. Most importantly, such medical care can lead to at times hypo and hyperglycemia condition of our patients due to poor insulin titration. This in turn may result in longer hospital stays and higher medical costs. Our solution is to leverage artificial intelligence and machine learning, abbreviated as AI/ML, to support our clinical decision process. Unlike black box AI tool, we further integrate our mechanistic understanding of insulin control in our body via what we term as quantitative system pharmacology or QSP models, which will offer physiological understanding and the ability to explain the solutions that we are providing to our patients. This system will be integrated into our existing clinical workflow via dashboard for real-time patient care. In summary, our solution has the potential to improve time in range, safety, and efficiency of insulin administration while reducing clinician burden. OPTIM AID is an integration of AI/ML, QSP, patient data, and our current care plan for optimizing the precise titration of insulin through mechanistic and AI-based inpatient decision support tool. And the outcome is to ensure safe and efficacious glycemic management using insulin as the therapy. This is the outline of our solutions, which at the outset involve the collation of clinical data such as the meal plan, the insulin logs of our patient, the patient clinical parameters, and the expert clinical inputs from our clinician. Data curation and cleaning will be performed to ensure structured time series patient data set, which will now subsequently be input into the first mechanistic QSP model, where it will incorporate our understanding of glucose insulin homeostasis, the physiology of the patients, the metabolism of insulin, and at the same time its pharmacological effect. The QSP layer will also allow us to generate digital twin of patients, which further augment the clinical data needed for training the AI and ML layer. The AI/ML layer will now collect real-world data and using machine learning tools to predict the trajectory of insulin and trajectory of glucose for developing the clinical decision. As shown here, this process is iterative, and the AI/ML layer will be continuously trained using real-world clinical data and at the same time synthetic data generated from the QSP layer. This system will undergo negotiation and interrogation by clinicians and subsequently optimized for clinical use. This is the front-end design mock-up for the OPTIM AID. As you can see here, in this hypothetical scenario, we have the clinical context of the patient, and at the same time, we can make use of all these prediction to map out the trajectory of the glucose according to the insulin doses. We also have situation where clinician can predict a priori the trajectory of the glucose based on the changes in the insulin doses. There will be intuitive interface for the clinicians to obtain data in order for them to manage the patients judiciously. The team comprises experts with clinical pharmacology knowledge, quantitative system pharmacology knowledge, modeling and simulation expertise, artificial intelligence and machine learning knowledge, and at the same time, clinical pharmacy knowledge from both NUS and the Tan Tock Seng hospitals.